In this video, we are going to look at differentiation of functions from first principles. I'm going to first look at a curve, a function f of x. So consider this function y is equal to f of x. So I have a function y is equal to f of x given to me. On this curve, I'm going to mark a point A. So I have a point A marked here. Let its x-coordinate be taken as x itself. So that's the x-coordinate of the point x there. So x-coordinate is known to me, which is x, and so the corresponding y-coordinate will be y is equal to f of x. So y-coordinate is f of x. If the x-coordinate was 2, y-coordinate would have been f of 2. If the x-coordinate was chosen as 10, the corresponding y-coordinate would have been f of 10. So I have the x-coordinate written as x itself. So the corresponding y-coordinate would be f of x. So that is x comma f of x, the coordinates of A. I'm going to mark another point B on it, which is h units to the right of A. So my point B is taken in such a way that it will have an x-coordinate which is h bigger than x. So this x-coordinate here would be x plus h. So the x-coordinate is x plus h. And the corresponding y-coordinate will be f of x plus h. Because if the x-coordinate is 2, y-coordinate would be f of 2. If the x-coordinate is x plus h, the corresponding y-coordinate will be f of x plus h. So I know the coordinates of B as well. I know the coordinates of A, I know the coordinates of B. I'm going to join A and B. So when I join A to B, I get a chord AB. I'm going to calculate its gradient. The gradient of the chord AB is y2 minus y1 by x2 minus x1. It's the y difference over x difference. y2 minus y1. This is my x. This point A is my x1 y1 and B is my x2 and y2. So y2 minus y1, y difference, f of x plus h minus f of x is the numerator. F of x plus h minus f of x divided by the denominator, x2 minus x1, x plus h minus x and x will cancel, that will give me divided by h. So I get f of x plus h minus f of x by h. So that's the gradient of the chord AB. Now, if I talk about the gradient of the curve, when I talk about the gradient of the curve, what I actually mean by that is the gradient of a tangent to the curve. So at this point A, if I want the gradient of the curve or gradient of the function f of x, what I need to do is I need to find out the gradient of the corresponding tangent at A. What I have drawn here is AB, a chord, but I want to make it into a tangent now. Now what is a tangent? A tangent is a line which touches the curve only at one point, not intersecting a curve. This is intersecting the curve at 2 points. I want a line which just touches the curve at one point, and that too I am considering the point A. So I want a line which touches the curve at A. So what I'm going to do for that is I'll move this point B along the curve closer and closer to A. Push this down. Get this point B closer and closer to A. How can I do that? I said consider a point B in such a way that it is h units to the right side of A. H units bigger than x it is. Yeah, that's how we got the coordinate as x plus h. So what if I make my h smaller and smaller and smaller? Like this, you make it smaller and smaller and smaller. H goes smaller and smaller and smaller. So x plus h becomes x plus h, this point becomes very, very close to x. Or rather, I can say that B gets closer and closer and closer to A. And if I say H is becoming 0, oh no, we don't say H becomes 0, we say as H tends to 0, as H becomes very, very, very small, as H tends to 0, B gets very, very close to A, and in that case your AB turns out to be a tangent there. So AB becomes a tangent. So the gradient of that tangent will be same as the gradient of AB, provided h is very, very small. So I'm going to talk about the gradient of the curve, which is actually the gradient of the tangent. So gradient of f of x, which is actually the gradient of the tangent, is exactly same as the gradient of AB, the chord, provided h is very, very small. And how do I say mathematically h is very, very, very small, or h is getting as close as possible to 0? So I say limit h tending to 0 of this gradient. Limit h tending to 0 of f of x plus h minus f of x by h. This is basically the gradient of AB, but I am considering h as very, very small. As h gets very, very, very small, your B gets very, very close to A, and thereby AB, the chord, turns out to be the tangent. So limit h tending to 0 of f of x plus h minus f of x by h turns out to be the gradient of the tangent, which is considered as gradient of the function or the curve f of x. This is called, what we found now is the limit which we found is called the derivative. The gradient is called the derivative of f of x. So the gradient of the tangent or the gradient of f of x which we found is called the derivative of f of x, and is denoted either by the symbol f dash x. Some people call it as f prime. So this is f dash of x or dy by dx. If I call the function as y, then I write it as dy by dx. If I call my curve as function as f of x, I write it as f dash of x. So dy by dx or f dash of x is limit h tending to 0 of f of x plus h minus f of x by h. This process, the process of finding this derivative, f dash of x or f of x, using the basic definition which we found before, is called differentiation from first principles. So differentiate from first principles means find the derivative f dash of x or find the derivative dy by dx using this basic definition. Okay, so let's try one or two questions using first principles, finding the derivative of a function using first principles. So here you have a question. Find the derivative of f of x is equal to 2x cubed from first principles. So what I'm going to do is, this is my function f of x. I'm going to write my basic definition of f dash of x, the derivative definition, first principles. F dash of x is limit h tending to 0 of f of x plus h minus f of x by h. I'm going to sub into this formula. So I'll say f dash of x is equal to limit h tending to 0 of f of x plus h. Let me see what is my f of x. My f of x is 2x cubed. So if I need to find out f of a, it would be 2 times a cubed. If I want f of a plus b, it will be 2 times a plus b cubed. And if I need f of x plus h, then it will be 2 times x plus h the whole cubed. So I get it as 2 times x plus h the whole cubed minus f of x. F of x is the same thing as 2x cubed, just copy it. So minus, I'll copy my f of x, which is 2x cubed. Now this is x plus h the whole cubed. That looks like a plus b the whole cubed. So what I'm going to do is I need to expand this x plus h the whole cubed, for which I'll use my Pascal's triangle, 1, 1 and 1, then 1, 1 plus 1 is 2 in the middle, and 1, 1, 1 plus 2 is 3, 2 plus 1 is 3, and end it with 1. So these are the coefficients which I use to expand x plus h the whole cubed. So that's equal to limit h tending to 0 of 2 times x plus h the whole cubed. I'm going to expand. I take the first coefficient 1. When I say 1, it is x cubed, plus the next one is 3, the coefficient. When I write 3, x cubed changes to x square, and to compensate you will have h raised to 1. Total degree should be 3 always. Plus the next coefficient is 3. I write that 3. So now x square becomes x raised to 1. To compensate, h becomes h squared plus the next coefficient is 1, and when I write 1, x completely disappears because it was 3, then 2, then 1, and it is disappeared. So h square became h cubed now. Minus 2x cubed stays there divided by h. Now I open the bracket with 2, so when I open the bracket with 2, so I get 2x cubed plus 6x square h plus 6xh square plus 2h cubed. That's opening the bracket with 2 minus there is 2x cubed still divided by h. You can see that two of the terms will get cancelled there. 2x cubed and minus 2x cubed will get cancelled. I'm going to copy the rest of it. So limit h tending to 0 of. That's what I have balance. And from the numerator, now there is an h common factor. Actually, there is 2h common, but I am not really worried about that. I take an h common, so I have 6x square. If I take an h out, I have 6x into h. Because it was h square, I took 1h out. This is 2h cubed, but I took an h out, so I have 2h square divided by h. Then you can see that h and h is cancelled. Now I can apply the limit as h tending to 0. If h is tending to 0, the second term will become 0, the third term becomes 0, 6x square will stay. So I get 6x square plus 0 plus 0. So that's 6x square. So I write my conclusion. Therefore, f dash of x is going to be 6x square from first principles. Let's look at one more question. F of x is equal to 2x square minus 5x. Find f dash of x from first principles. So that's my question. I write the formula first. F dash of x is equal to limit h tending to 0 of f of x plus h minus f of x divided by h, which is equal to limit h tending to 0 of f of x plus h. What's the meaning of f of x plus h? This is my f of x. F of x plus h means into my f of x. Wherever I see x, I should make it x plus h. So this is going to be 2 times x plus h the whole square minus 5 times x plus h. That's my f of x plus h. But I need to still write my minus f of x. So I'll put a minus sign, and then f of x should be copied in a bracket because of the minus sign. So here I have my f of x plus h. I got it by replacing x everywhere by x plus h minus f of x. I just copy as it is, but in brackets. I'm trying to expand this now. To expand this, limit h tending to 0 of 2 into, this is like a plus b the whole square. What is a plus b the whole square? A squared plus 2ab plus b square. So that's going to be a squared x squared plus 2ab, 2 into x into h, plus b square is h square. So a square, which is x square, plus 2ab will be 2 into x into h, plus b square will be h square. Then I open the bracket with minus 5, so minus 5x and minus 5h. Here I open the bracket with the minus sign, so I get minus 2x square plus 5x. Divided by, you still have h, and I try to cancel some of the like terms. I have a minus 5x here, which cancels with plus 5x. If I open the bracket, it will be 2x square, which will cancel with minus 2x square. The remaining terms when I copy, so it is 2 into 2xh is 4xh, 2 into h square is 2h square, there is minus 5h by h. There is h common, take h common out of the numerator, balance is 4x plus 2h minus 5 by h and h will cancel, and I apply the limit as h tending to 0. When I apply the limit as h tending to 0, 2h will become 0, the other two terms will stay. So my answer is going to be 4x minus 5. You need to look at the textbook and practice more questions on it. So what you could do is, if you haven't understood any of these concepts which I have explained, you should go back and watch it over and over again until you understand it. Pause the video, write them down and practice it.